Welcome to Metal Welding Lecture Series by Professor Joyjeet Ghose. This is the 8th lecture of a series of lectures. This lecture will be on Thermite Welding Process. He will be discussing about Thermite Welding Process, various types of thermite mixtures, thermite reactions and thermite welding applications. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture 8 of a series of lecture on metal welding processes. In this lecture we'll be discussing about thermite welding. The thermite welding probably was invented by British Railways, and they used this welding to join broken railway tracks. So essentially this welding process is used for welding of normally broken or large plates, pipes, cables, rails. So it is even nowadays it is common to use thermite welding on site for welding of broken rails, and it's an efficient and a simple technique for such kind of welding processes. So how it happens here we'll discuss. So it's a fusion welding process, which basically means the metal to be joined are melted. However, here the heat is obtained from a exothermic reaction of thermite mixture, and because of these exothermic reactions of the thermite mixture, in the mixture we obtain a molten metal, and that molten metal when poured, which is a very high temperature, which poured on the metal surfaces to be joined, also melts it and forms a coalescence. So for this we use a thermite mixture which is customized or custom for a particular type of material which we are joining. So for steel we have this thermite mixture which is a mixture of finely divided aluminum and iron oxide. So this finely divided aluminum and iron oxide is a thermite mixture. So this, when placed in a refractory crucible and ignited by means of a highly inflammable powder which is called barium peroxide. So if you introduce barium peroxide to this mixture, an exothermic reaction takes place, and the reaction is somewhat like this. It produces a heat, and as well as this iron is melted and is deposited in between the two metal pieces which you are joining. Now in order to deposit exactly between the two metal pieces which you are joining, we require a mold. So therefore in my opinion it is a crossover between a casting process and a welding process. Why I say it's a crossover between a casting process and a welding process is that here we are melting the metal and pouring it in a mold, and why I'm calling it a welding process, because it is joining a process. So it is essentially both a casting process as well as a welding process. So here we require a mold. Now the mold is required to restrict the movement or the flow of the molten metal in between the two metal pieces which you are joining. So for that you require the mold, and so there is a crucible in which we pour the thermite mixture and ignite it with the means of barium peroxide. So this gives an exothermic reaction and produce a large amount of heat. The heat is sufficient to and iron is also produced. So iron is poured in between the two metal pieces, in this case the rail tracks, and the heat is sufficient to melt the metal pieces which you are joining. So it will be joined, and normally you have a lump over the two metal pieces which you are joined, and the excess material is removed by grinding process. So this is what we normally follow in railway track repairs. So for that, first you have to cut the railway tracks properly and make it flat and come it to a butt joint, bring it to a butt joint position at the end to end, and then build a mold around it, and then start the reactions. So this is mainly for iron based ferrous material, and for copper material, this method is also used for joining of broken cables, power cables. So in such cases we will be using this cuprous thermite mixture or cupric thermite mixture accordingly, and the heat produced is of course much less compared to that of the iron one or ferrous one. So this is the basic principle of this welding process. So in YouTube you can search, there are large number of actual videos showing the thermite welding process, very interesting. I highly recommend you to visit these sites or YouTube videos and watch the video, then it will give you a holistic idea about the process. So the application, as I have said, for welding or repair of rails, pipes, cables, shafts which are broken, rebuilding of large gears, etc., etc. Advantage is that it gives a sound and free of internal residues, the welding, and broken parts can be welded on site. That's very important in railway tracks. If if it is broken, so every time you cannot have that removed and bring it to a workshop and repair it and send it. So sometimes you have to weld it on site. So this is very simple things. Kits are available. You carry the kit and then go there and carry out the welding process. I'll show you some pictures which I have downloaded from the net. The source I don't remember, and I'll show you how it is done. So you can see the mold here, and this is the crucible, and the reaction takes place and it will be deposited here. So here first it is cleaned properly, mold is prepared, firing is done. Once the firing is done in the crucible, then you can see the molten metal is dropped here, and then this mold has to be removed by an hydraulic device. So this is removed. After that, the excess metal which has been deposited between the two metal pieces which you have joined, or two rails which you have joined, is cleaned by some grinding process, and you can see the final product here, final welded product. So this is the basic process of thermite welding. So that's it in this lecture. In the next lecture, we'll be discussing about resistance welding process. Thank you for watching this video.